All right. Does it say recording? No, it doesn't. Of course not. It says that would be awesome. No, it's recording. Do you guys get a message that we're recording? Oh no. Unable to sync changes. Please check your network. Okay, that means I gotta go outside. Wait, let me see. Refresh. Come on. Refresh. 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 All right. It says it's recording. You guys hear me? Oh no, 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 no. No, 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 no. It's too loud. How about now? You guys hear me? I'll figure this out. Don't worry, I'll figure it out. There has to be a spot where it's the least amount of noise. You guys there? I need feedback because if not, I don't know what I'm doing. I see movement of people's heads. Can somebody talk to me? Can somebody guys talk to me? Nobody wants to talk to me? Huh? Right, chat. That says something. It's getting better. How about now?
Mr. We hear you good.
Okay. So can I, all right. So any questions on the homework? I'm just going to chill here then. Any questions on the homework? Number 3. Okay, so number 3 is this guy down here, right? It's easier for me when you guys talk to me. Just talk to me, bro.
Yes, that one.
What part of number 3? Anyone?
B.
Okay, so let's go into 3B. So it says use of R equals R squared. Now this is basically a formula they're giving you to determine the terms of the sequence. So we begin with 1. If you put 1 in here, you have use of 1 equals 1 squared, which is just 1. And if you put in 2, you have use of 2 equals 2 squared, which equals 4. And then you put 3, use of 3 is 3 squared, which is 9. So I guess you could tell that for 3B, you would have 1, 4, 9. The next one would be 16, 25, right? Would this be the sequence for this? It's really loud here. Would this be the sequence for this, guys?
Yeah.
Okay, so now let's try and see. This is, I guess you could say, this is deductive, I guess. We want to do an inductive definition. So use of 1 is definitely going to be 1. So what is going to be use of R plus 1? What are we doing? Anyone? Anyone? Give me 1 second. Dilo, Denny. What? ¿Cómo está, Denny? Es hoy. No fue ayer porque tuvo una emergencia en el trabajo, lo pusieron presión, pero hoy te arranque completo y mañana va el electricista a hacer el trabajo tuyo. Porque él no puede hacer nada hasta que él termine ahí. Ya no faltaba venir el inspector hasta que terminemos ya lo que terminó el inspector fue la plomería el otro día. No tenemos inspecciones hasta hasta que tengamos la estabilidad del puesto. Para jueves, para jueves. Ya te deja todo lo, te deja la luz puesta, te deja T4000, el panel y todo puesto como para cuando se vaya a poner los equipos. Ok, so, lo correcto hacer eso, después que pasa la inspección electricista de él, se compra la tubería esa y se tira para abajo. Porque si el inspector se pone pesado y lo ves, te embarcas. Entonces, si lo hacemos, tú sabes, tranquilo. So, hoy muchacho deja eso que es sacado y después mañana necesita vaya a hacer su trabajo. ¿Está bien, Nen? Bueno, todo sabe. Bye, bye. All right, sorry about that, guys. So anybody have an idea what to do there for inductive definition? Come on, guys, I gotta pretend to be a teacher. Come on. Did anybody try it? No? Okay, let's work on it together then. All right. So what's clearly happening here? All right. When I put R equals, go ahead.
It will be UR squared.
No, my mom didn't even her.
All right, so you said it's gonna be U's of R squared, right?
Yes.
Let's say we put 1 in there. U's of 1 plus 1 equals U's of 1 squared. So U's of 2 equals to 1 squared equals to 1. Is that true? Is U's of 2 1?
No. So it
No.
has to be plus one, maybe. No.
Let's go to the drawing board again. Okay, let's just think about it. All right. You know that it was 1 plus 3, but then it was 1 plus 5, but then it was 1 plus 7, and it was 16 plus 9. The next one should be 11. So would I want to work like that? How do I want to do this? Did anybody try for homework? I want to show you something. Okay, so we are here. We are here at U's of 2 when R equals to 1. Now, how can you add 3? How can you add 3? Or would you want to add 3? Okay, watch. Let's do it another way. Let's say I had to figure this out. Okay. Oh, we got somebody else coming in. Jebly, finally. All right. Let's say we had to figure this out. We're going 3, 5, 7, 9. How can we write that? Then I go, all right, so look, watch this. What's n squared minus 1? I mean, let's do r squared. What's r squared minus 1? Let's say you put a 2 here. 2 squared minus 1, isn't that 3? All right, but now we need to go ahead and do 5. Would 3 squared minus 1 equal to 5? No. So that trick doesn't work. So let's go ahead and think of other things. Because here's what you need. You're going to need 1 plus 3. For use of 3, you're going to need 4 plus 5. For use of 4, you're going to need 9 plus 7, right? So how do you create 3, 5, 3, 5, 7, 9? Where your R's, remember, in this case here, your R is 1. This case here, your R is 2. In this case 3, your R is 3. In this case here, your R is 4. How about this? This is your R's. Yay or nay? Yes? Does that make sense? But you have to be clever. And I'm not clever. But you see how it worked out? Okay? Do you understand? Obviously, there has to be a pattern, there has to be a way of seeing it, but that's how you define it inductively. Fair enough? You guys can talk, you turn on your mic. It just feels like I'm talking to myself, bro. Come on, wonderful people. Nobody wants to talk to me, bro. What's wrong with you guys? Yay or nay? Is there something? Wait, come on. Come on, turn on your mics. Go. Yes, nay, yes, no. Someone. Everybody's mic is off. Do I have them everybody switched off? Let's see, wait. Watch. Let me just ask somebody to talk. Watch. I'm gonna ask. Guys, turn on your cameras. What? Celine, turn. Wait. And somebody's upside down. Oh my God. Celine, did you understand the
Hi.
question? Hello, how are you?
Sort of. I'm still struggling.
Okay, so let's do this. I'll review more of it. Let's not waste too much time on this. Let's move forward. Okay. I mean, I know that's kind of like the whole point of the homework, kind of, but did you see how I created that? Yes or no? No?
Yes.
Okay. Now, any questions on number 4? Questions on number 4? Let me see. I have something in the chat. Erica said no. Okay, fine. Anybody else besides Erica? Let's see. Jebly, no. All right. I think third time's a charm. All right. Anybody else besides Jebly and Erica are cool, or do you want me to go over something else? Guys, remember, I'm pretending to be a teacher and you guys are pretending to be students.
Can you do 4?
Which one of 4?
E. Oh, no. Let's do F.
Let's do F. Okay. I hope I can do it. Let's give it a shot. let me tell you, I don't like doing these problems because they don't feel natural to me. Okay, they don't feel natural to me. So, some people actually do very good at this. Give me a second there, and then we're gonna extend our lesson. Give me a second. There's more chatting stuff. 4F, 4F, 4F. Okay, so it must be a hard one if you guys are asking me to do it. All right, so let me erase all this. Actually, I can just use the last one. Well, yeah, here's the last one. Let me last it. All right. Oh no, there's more concrete. I thought the concrete was over. When the concrete's over, I gotta run over there and get the ticket. All right, so 4F. It says here, for each of the following sequences, give a possible formula for the ARF term. So let's give it a shot. 4F. 2 divided by 2, 5 divided by 4, 10 divided by 8, and 17 divided by 16. So we're not doing a deductive, okay? So let me see. So use of 1 is 2 over 2. Use of 2 is, now here's how I think of this. All right, I'm like, okay, how do I go to 2 over 2? How do I go to 5/4? 5/4. 5/4 is 1 1/4. So I can add a quarter, but let me see. I can add 1/4 to 1 to get to 5/4. Let me see what this one is. This is gonna be 1 2/8. Is that correct? 1 2/8? That's actually gonna be 1 1/4. I don't like that. Give me a second. I don't like that. It's 1 2/8. Does everybody agree it's 1 2/8? In other words, if I wrote it correctly, this is also 5/4. And the next one is 17 over 16. So that is 1 1/16. Okay. So this is problematic because we got 5/4, and then we got 10/8, and then we got 17 over 16. All right, so I don't like this because it went like this. Let me just rewrite it up here. Right here, it added 1/4, let's say. But here it added 0. But then here, it subtracted. We gotta see what's happening. It subtracted. What's 1 1/4 minus 1/16? I can't do it in my mind right now. 4/16. 4/16 minus 1/16. It subtracted 3/16. It subtracted 3/16. So that's really weird, guys. Is there any other pattern? For instance, I see another pattern. In the denominator, before you're going 2, 4, 8, 16. So this is 2 times 2. This is 4 times 2. And this is 8 times 2. Right? So for use of 1, this is use of 2. So I guess you could say, let me just say R equals to 1 here, 2 here, 3 here, and 4 here. All right, so can we establish a formula for that? Let me try a different way. This is 2 times 1. Then this is 2 times 2. Then the next one is 2 times 2 times 2. Then the next one is 2 times 2 times 2 times 2. So this is 2 to the second. This is 2 to the third. This is 2 to the fourth. This is 2 to the first. So for the denominator, you could just say it's 2 to the R. Now for the numerator, we got to figure out a wait, chat. Yes, yes, Gabriella. It's 2 to the R. I just now what about the numerator? Let's observe the numerator. We got 2, we got 5, we got 10, and we got 17. So how do we do that? No one? That one's difficult. We figure out the denominator. Can we figure out the numerator? No one? So think about it. You have this one, 2. Then if I had to add 3, for example, and then I have to add here 5, and then I have to add here 7. Chat. I don't know about the numerator. The numerator is tough. But notice that we have 3, 5, 7. Can we replicate the 3, 5, 7? We want to replicate the 3, 5, 7. Okay, an easy way to replicate the 3, 5, 7 is kind of like the question we did earlier. For instance, when we did 2n minus 1, when we did 2 times 2 minus 1, we got 3. When we did 2 times 3 minus 1, we got 5. When we got 2 times 4 minus 1, we got 7. So that's how we can replicate this, this, and this. If you put 1 in there, you get 1. You see? So how would you write the numerator? You know you want for n equals to 1, you want it to be a 2. When n equals to 2, you want it to be a 5. So think about it. For instance, if I put the following, 2 plus 2n minus 1, what do I get? I get 5. When n equals to 3, I should get a 10. When I put 2 plus 2n minus 1 equals 2, yes, somebody wrote 3r minus 1. Well, let's see. I think it will work. Okay. 3r minus 1. 3 times 1 is 3 minus 1 is 2. 3 times 2 minus 1 is 5. Yes, it works fine. It works fine. Now, could we, did, in the line of reasoning I was using, that 6 minus 1 is 5, we don't get 10. 3r minus 1 works perfectly. How do you come up with that? Because it probably was going to take us a little while to figure that out. Because when we did this here, what was important is that we added, it had to be 5. And that was the major part to make this work. So the answer is this. Definitely it's this. But do you see that you have to be clever? You have to be clever. These guys are yelling in the background. Okay, about 1/3 of the pool is done almost. All right, let's move on because we're spending an order amount of time. How much more time do we have in class? How much more time do we have in class, guys and gals?
55 minutes.
55 minutes. That's a long time. Okay, so let's go ahead and lasso this out. Let's not spend too much more time on this. It is challenging. Those problems are challenging. You have to sit there. And the reason is that they're not obvious what to do. You got to play with it. Okay. Let's go ahead and look at down here. Now, remember that last class I talked about the triangle number sequence, right? That is that if we take 1, 2, 3, 4, 5, 6, 7, right? And we want to add those numbers up. We said that, so if this is n equals to 7, we said, oh, well, if we want to add them all up and get the sum, we would just take 7 times 8 divided by 2. Because the formula was n times n plus 1 divided by 2. Remember that we did it last class? Guys, I need somebody to talk. Because I don't have feedback. Yes?
Yes.
Okay, now, that means, let's just quickly do this. If I say, I want the sum of 1 through 37, how would you do it? Tell me what you would do. One through 37, I want the sum. What will you do? I don't hear anyone. One through 37. I want to add up all those numbers from 1 through 37. What do I do?
You add the last and the second one.
So you take 37, you multiply it times 1 plus 37, or 37 plus 1, and then you divide by 2. That's what you do. Let me do it on my calculator, guys. It says 703. Chat. Let me see chat. Yes, 703. Nayalis. You can talk too, Nayalis. All right. So now let me introduce to you the concept of factorial. Now, usually in class, I'll go through it differently, but since I'm out here, I'm just going to go directly to the questions. Okay? Take a look at 7 right here. This means 7 factorial. Now, here we're adding 1. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Here, we're gonna multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. That is what it means to have factorial. That's what it means to have factorial. Okay? Questions or concerns?
No yet.
We're good?
Yes.
Yes. Okay. Now, look at no 3b. You got 8 factorial divided by 3 factorial. So tell me, how would you evaluate that? Anybody? I'll just go ahead and make an arrow to give me more space to write down here. So 8 factorial divided by 3 factorial. Talk to me.
So it'll be 8 times 7 times 6 times 5 and so on. And then 3 times 2 times 1.
And what did you notice? Look at this. So this is really 8 times 7 times 6 times 5 times 4. You see that?
Yeah.
And you can do that without calculator. That's going to be 56 times 30 times 4. That's 56 times 120. 120 times 56. 6 times 0 is 0. 6 times... Uh-oh, internet connection's unstable. Let me get closer to the house. Wait, got to go back to another spot. Wait, somebody's chatting. You're cutting off completely. Okay, I'm coming back. I'm coming back. Coming back. I'm just trying to get some sun because it's cold out here. It's cold out here. All right. Can you guys hear me better? Oh, chat. 6720. Oh, you calculated. Well, just check my math, right? $67.20 is correct. All right, so now you should be able to do this one. But now, can you do number 4? Can you do number 4? Like, for instance, look at number 4A. They write the following. 8 times 7 times 6 times 5. How can I write that in terms of factorial? Look.
8 factorial divided by 4 factorial.
Yay, yes, that's exactly right. Give me 1 second, guys. I got emails. Got it. So, easy, right? How about questions or concerns, guys? Anybody like lost what happened there? Look, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. That's how, you see? Now, what if I ask you to do (4D), which says n times n squared minus 1. How do you write that as a factorial? Let me help you. Let me help you. Let me help you again. Do you see? Do you see why this is the answer? To that, chat says. Oh, yes, Jebly, correct. You see it? Yes or no? Come on, guys, help me out. Trying to be a teacher here. Chat, more chat. Yeah, yeah, I get it a little. What do you mean a little bit? Yes, see it. Yeah, 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 yeah. Anybody else? I just need more examples. Okay, let's get another example. Okay, so let's go back up here. And let's do F. We have n plus 6 times n plus 5 times n plus 4.
N plus 6 divided by n plus 3.
I was not talking.
Make sure to write the factorials. There you go. That's it. That's exactly right. Jebly, do you understand it? Yay or nay? I just need more examples. Man. That's what he wrote. He wrote man. Well, I don't know what else to do. That one was super easy. How about C? C says, guys, the concrete finished, so I gotta go. I'll be right back. Oh, chat. Wait, never mind. I got it. All right, fine. So, Jebly, if you got it, tell me 4C, what's the answer? What's 4C? What's the answer to 4C? Let me see. I'm trying to figure it out. All right. What about the numerators n factorial divided by n minus 3 factorial? Does that make sense, what I wrote there? All right, guys, give me a second. I gotta check on the ticket. I'll be right back. Let me pause the recording of these questions. I'll try to answer a little bit more from your homework next class when I'm in front of the board and we can work it out together a little bit more easily. But any questions so far on number 4 there? Any questions on number 4? No? Okay, so how about number 5? Do you guys wanna take a crack at a few questions on number 5? Yes or no? Guys, you gotta help me. Come on.
Can you try 5C?
Yes, I'll try it. I'll give him my best shot. Let's go ahead and take a look at 5C. All right, so it says there n plus 1 factorial divided by n factorial. Simplify it. So we got n plus 1 factorial divided by n factorial. What is it going to be? I want you to, when in doubt, write it out. Like, start writing it out. Can somebody tell me how to write n plus 1 factorial? According to our definition of factorial, as we've been doing it. Come on, wonderful people, help me out.
No, n plus 1 times n.
Okay, so all right, so watch. Pretend, pick a number for n. Tell me a number for n, guys. Just pick a number, somebody. Like, not a big number.
6.
All right, so let's just say I wrote the following. I wrote 6 factorial. What would the top one have to be? What's 6 plus 1?
7.
So what does this come out to? This is important because if you don't understand that one, you won't understand, the one with the
7.
There you go. Because this is 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. And all this cancels and we're left with just 7. So in this case, the same thing happens. This is n plus 1 times n minus 1 times n minus 2. And in the bottom, it's just n times n minus 1 times n minus 2. All these cancel. So we're just going to be left with n plus
1.
Yay. Got it? Yes or no?
Yes.
Amazing. How come you guys don't want to interact with me? Yeah. All right. Oh, Nayeris wrote 7. All right. All right, guys. So, okay. So now I need to continue. Okay. So I think today we have enough time for me to present what is an arithmetic sequence and figure out how to do an arithmetic series. And I'll post some homework. And next class, we're going to go ahead and tackle it. Okay. Fair enough? Yes or no? Maybe, sort of, kind of. Nobody cares?
No, we care.
Okay. Can you point at the people in class that don't care? You don't want to do that? Okay. But we can figure out. Ask Jebly to do the pointing. I want him to point at the people who don't care because he doesn't care. Is he pointing at people? Is he even in class? Is he in class? He is in class, right? Okay. Did he point at people that don't care? Let me see what it says. Yes, Jebby, you're here, but that's not what I said. I said to point at people who don't care in class. Like point at them, like you don't care, like just do it, man. How? I don't know. You don't you have like a third sense on how to do that? No, I'm not you. What? All right, guys. So let's talk about what's an arithmetic sequence. So an arithmetic sequence, strictly speaking, is just a set of numbers that you get the next one by adding the same number over and over again or subtracting. So let's say, chat, let me see. I don't got the courage. Oh no, this is how you develop courage. And then you become ostracized by people like you calling them out. But yes, I'm putting something on you that I shouldn't be. But anyways. Wow, I don't got the courage to do that. Or yeah, just look around. They're very close to you, some of them. Some other people on the other side of the class. Anyways. All right, so an arithmetic sequence. So let's start with, let's say I do the following. I say here's 5. And let's say I want to add 2. What's the next number after 5 if I add 2 to it? Five plus 2.
-1.
5 plus 2.
7.
What's 7 plus 2? What's 7 plus 2?
If I add
9.
9.
it's
All right, people are writing, chatting. 9, 9, 9, 9, 9. Okay. Next one is 11. Next one is 13. Next one is 15. Next one is 17. This is an arithmetic sequence. The first term here, we call A's of 1. The first term is 5. D is our common difference, is 2. This is called our common difference. We always figure out the common difference, not always, but usually by taking 2 consecutive terms and subtracting them. So in this case, if you take, this is the first term, this is the second term, this is the third term. If you take the third term and subtract the second term, you're going to get the common difference of 2. Okay? So 7 minus 5 is 2, but so is 9 minus 7. So is 11 minus 9. So is 13 minus 11. So is 15 minus 13, and so on and so forth. Okay? Now, for instance, I can have a different set of numbers. I might have the following. I might have 12, and then if I subtract 3 to 12, what do I get? 9. And I subtract 3 to 9, what do you get?
Is it a question?
Did I subtract wrong, guys? Come on, help me out. Say again. Was that a question?
6.
6. 6 minus 3. 3. 3 minus 3. 0. 0 minus 3. -3.
3.
This is an arithmetic sequence where the first term is 12 and the common difference is 9 minus 12, for example. It's -3. So you could have a common difference of -3, but the key here is that you're adding or subtracting by the same number over and over and over and over again. Agreed? Yes or no? Yes or no? Yes or no? Come on, wonderful people that don't want to communicate.
Yes.
Obviously. Great, great, great. All right. So now I want to develop a formula that we can use to determine any particular portion of our sequence. All right. So let's begin. Let's just do you guys want to do this with letters? Do you guys want to do this with letters?
Sure.
Sure. Okay. So let's start with A's of 1 is just A. Right? I should use another letter, should I? No. Okay. Okay, fine. I can use that. Now, A's of 2 is A plus the common difference. I should actually write this. I should say that it's A's of 1 plus the common difference. So A's of 3 must be A's of 2 plus the common difference. But A's of 4 must be A's of 3 plus the common difference. So in general, A's of n must equal A's of n minus 1 plus the common difference. I can write that. But what I want you to see is that if we go back, A's of 2 equals A plus D. A's of 3 must equal A plus D plus D. A's of 4 is A plus D plus D plus D. So notice that I have A plus 1D, A plus 2D, A plus 3D. See, notice when we're at 4, we have 3Ds. When we have 3, we have 2Ds. We're at 1, we have, when we're at 2, we have 1D. And when we're at 1, we have 0Ds. So when we're at n,
So it's plus 1.
well, it's plus 1. Yes, correct. And we're here, this you can say A plus n minus 1D. In other words, you can say that A's of n must equal A's of 1 plus n minus 1 times D. That is the general way you can figure out any term in a arithmetic sequence. If we come up here, they wrote it up here. No, here. This is what they wrote. Now, let me show you how this works. For instance, let's go back to here. If we use the formula A's of n equals A's of 1 plus n minus 1 times D, and I say that the first term is 5 with a common difference of 2, you would write, well, A to the, let's say we want to figure out the 5th number. A to the 5 must equal 5 plus 5 minus 1 times 2. So this is 5 plus 4 times 2, which is 5 plus 8, which is 13.
Mister, can you go back to the other one, to the A?
There? Is it there you want to be at?
Yes.
Okay.
Okay, thank you.
You're welcome. This computer eats a battery. I'll set 59%. It just looks more. I got plenty of battery. Let me start charging it for next period. Are we good with this, guys? Okay, so
Yes.
you see when I did it here, A to the 5th came out to 13.
Yes.
Then when we saw here, you can figure out what term you're in or what term you're going to get if you know the common difference and you know the first term, because you can use that formula. Now, here's the thing. When we did the triangle number sequence, when we had 1, 2, 3, 4, 5, this is an arithmetic sequence. This is an arithmetic sequence. Is A's of 1 equals to 1, and the common difference is 1. It's a specific type of arithmetic sequence. Now, we said that we added this up together, we would just use the following formula: n times n plus 1 divided by 2. And remember, we went like kind of like this in class. We went, you know, like, hey, 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7, right? That's what we said. Now, when you add up a sequence, when you add a sequence of numbers, okay, we call that a series. The sum of a sequence, is a series. So we want to maybe figure out, since there's a way to use a formula to figure out each new term, we want to maybe figure out if there's a way we can add that we can get a formula to figure out the sum of a sequence, because we might be interested in that. So what I want to do is, instead of doing it purely with letters, I want to do it with numbers first. Okay, so let's use the sequence we just made up. We use that the first term was 5, and then the second term was 7, and the third term was 9, and the fourth term was 11. This is a arithmetic sequence where the first term is 5 and the common difference is 2. Now, if I ask you to add terms 1 through 4, you have 5 plus 7 plus 9 plus 11. So that's 12 plus 9 plus 11. That's going to be 21 plus 11. So that's going to be 32. But if the sequence gets too big, I can't do it that way. So what I want to see is, I want to see if there's any patterns associated with adding these numbers where I can see if I can develop a formula. Now, the sum of 1 is 5, but the sum of 2 is 5 plus 7. The sum of 3 is 5 plus 7 plus 9, and the sum of 4 is the 5 plus 7 plus 9 plus 11. Now, what I want to do is maybe I want you to see that this is 5 plus 5 plus 2. This is 5 plus 5 plus 2 plus 5 plus 2 plus 2. So this is, I'll rewrite them again. This is 5 plus 5. Let me be careful. I write it plus 2 plus 5 plus 2 plus 2. All right, so that takes care of 9 plus 2. So let me rewrite this as 2 plus 5 plus 5. And this is 2 plus 2 plus 2 plus 5 plus 5 plus 5. And this is going to be 2 plus 2 plus 2 plus 2, 2 plus 2 plus 2 plus 2, plus 5 plus 5 plus 5 plus 5 plus 5. It looks like what's happening here, make sure I didn't miss a 5, guys, because I would hate to have missed the 5. I think I've missed the 5 somewhere.
You did miss a 5, I think, the last one.
Okay, where did that 5 was it? Where was it supposed to go?
Was it? Or
Well, let's be. All right, so let's see. 5 plus 7 plus 9 is 5. 5 plus 5 plus 2 is fine. So this is good. So now if we're going to do 5 plus 7 plus 9, it's going to be 5 plus 5 plus 2 plus 5 plus 2 plus 2. This is fine. Now, let me redo the fourth one because this is important because we got to see patterns. Without seeing the patterns, we can't develop a formula. We can't develop a formula, then what's the point of me doing this? All right, so let's take our time. We got 5, then we got 5 plus 2, then we have 5 plus 2 plus 2, and then that's 7, 9. Okay, so this takes care of 7. This takes care of 9. So now we have to take care of 11. That's 5 plus 2 plus 2 plus 2. Correct? This takes care of 11. So now we have 1, 2, 3, 4, 5, 6. 6 of the 2s. And then we have how many of the 5s? 1, 2, 3, 4 of the 5s. Okay. And what's 2 times 6 plus 20? How much does that come out to? $32. Now, here's what I want you to see. This is n. Okay? This is n. The 5s here are A's of 1s. That's the first term. So here we have 4 A's of 1. And how many of the 2s do we have?
6.
We have 6 of, and what do the 2s represent? The 2s are the common difference. So we have 4 A's of 1, and then we have 6 of the 2s. Right? Now let's take a look at the previous one. Okay? So for S of 4, damn, we're running out of time, guys. We have 4 A's of 1 plus 6D. For S of 3, what do we have? How many 2s do we have? I mean,
3.
sorry, how many 5s do I have? I should say that first.
Oh,
How many 5s do I
3.
have? 3 A's of 1. How many of the common differences of 2s do we have?
3.
Okay, 3. Okay, so we got 3D. For S of 2, what do we have? How many of the 5s do we have? For S of 2, how many of the 5s do we have?
2.
And then how many of the D's do we have?
1.
Okay. And how about S of 1? How many of the 5s do we have?
1.
And how many of the D's do we have?
0.
Okay, so the question becomes now, can we write out a formula for that?
Yes.
So talk to me. I know that S of n is going to equal n A's of 1 plus, and how do I get that 1, 3, 6, so and so on? How would I get that? In other words, what would the next one be? If I did S of 5, just to see if you see it, it would be 5 plus 7 plus 9 plus 11 plus 13. So that's going to be 5 plus 5 plus 2 plus 5 plus 2 plus 2 plus 5 plus 2 plus 2 plus 2 plus 5 plus 2 plus 2 plus 2 plus 2. So now we have to start counting. If I did everything right, we have 1, 2, 3, 4, 5, 5 5s, right? So we got 5 A's of 1s. And how many 2s do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 Ds. So for S of 5, we have 5 A's of 1 plus 10 Ds.
Mister, there isn't an easier way to do this?
Yes, there is.
Can you show us?
There. That's the formula. S of n equals half n times twice A plus n minus 1 times D. I would like to arrive to that to show you how to do that, but that's the formula. So we've run out of time basically. But I'm gonna go ahead and leave this meeting running, and I'll have next class do it. Let them know that I'm having a meeting. And in class, I'll try to show you the full thing so you can see it's kind of clever how they come up with this, how to do this. In fact, you've done this before. You've already done this. You have, I promise you. Sort of. And one of the questions in chapter 1, maybe we didn't do it. All right. All right, wonderful people. I'll leave the thing open, but we're pretty much on. Any questions or concerns? What I'll do is I'll put another video of me doing this, but this is the formula. There's 2 types of formula there. We'll discuss both, but basically I gave you this one. Okay. All right, so I'll go ahead and just stop this recording, and